हेलो। हेलो। हाँ, आप
Am I audible, sir?
Good evening, Lopa madam.
Good evening. Am I audible?
Yes, yes.
Okay.
Hello, Lupa madam. Hello.
Hello.
Lupa madam.
हाँ
Am I
Can,
audible to you?
Yes, 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 sir.
हाँ? सर, क्या Hello. Hello, Lupa madam.
Hello.
Good evening, madam.
Good evening. I am clearly audible? Am I clearly audible?
Yes, ma'am.
Okay. Okay.
Yes. Yes, ma'am.
Okay, thank you.
Okay. So, yes, ma'am. Okay. Okay. Good evening to all the participants. Welcome to the second day of the Atal FDP. So, welcome to the Faculty Development Program on Applications of Communication, Signal Processing and Robotics for Smart Cities for the day 2. So, the title of today's lecture is Data Driven Urban Mobility, the Role of Big Data and AI in Smart Cities. So, the expert for today's lecture is Dr. Lopa Mandal. So before we start the lecture, I would like to have a bio sketch of the speaker. So Dr. Lopa Mandal has 25 years of extensive professional experience in teaching, research, collaboration, and leadership in academia and industry in the field of computer science. She has completed her MTech or IT and PhD engineering from Jadavpur University, Kolkata. Her research interests include artificial intelligence, data analytics, distributed and cloud computing, mobile computing, and learning technologies. Currently, she is working as a professor in computer science and engineering department at Alliance University, Bangalore. She taught in other premier educational institutions including Institute of Engineering and Management, IEM Kolkata, St. Xavier's College, Manipal Global Education Services Private Limited. She has several research papers published in peer-reviewed international conferences journals and funded research projects to her credit. She is serving as a PhD supervisor in Maulana Abdul Kalam University of Technology, West Bengal, and Alliance University, Bangalore. She engaged herself in editorial activities in editing national and international books, journals, and magazines. Her editorial experience includes volume editor of edited book in Springer Nature book series, lecture notes in data engineering and communication technologies, advances in intelligent systems and computing, guest editor of journal special issue on computational intelligence and smart information. She has also been a volume editor of Nova Science Publishers, CRC Press, chief editor of an annual teaching technical magazine. She also served as a convener, organizing chair, and technical program committee member, session chair of different international conferences. Her application includes being a life member on both of Indian Statistical Institute and the Indian Society for Technical Education. She has also been an active member of Computer Society of India and served as a technical member of the CSI Kolkata chapter. So with this brief speech, I would like to request Lopa Madam to start the lecture. Over to you, ma'am.
Thank you so much for the nice introduction. I hope I'm clearly audible. So now I will share my screen. Okay, so my screen is visible.
Yes, visible.
Yes.
Okay, okay. Okay, so today my topic is data-driven urban mobility and the role of big data and AI in smart cities. So, keeping the theme of the FDP in mind, I will start my lecture with the brief introduction of what is smart city rather trying to define what is a smart city. So in the literature, we can see a number of definitions are available for smart cities. So I have taken only few of them. So the first definition, as per Tolley and Murtak, given by 2020, it is told that urban transformation that should aim to achieve a more environmentally sustainable city with a higher quality of life and that offers opportunities for economic growth for all its citizens. This transformation is currently enabled by various types of technologies that are enabled into the city's infrastructure system. This definition has been given by this particular researcher. So it is basically, we can see, highlighting the economic growth with technological advancements. Another definition also I would like to mention here, that is given by another researcher, Bibri, in 2021, that tells that a technologically and data analytically advanced city that is able to monitor and understand its environment and citizens, to explore and analyze various forms of data to generate useful knowledge in the form of applied intelligence that can be used to solve different problems or to make changes to improve the health of the city. So that is how another way it has been presented by another researcher. So we can, if we go to the literature, we can see many ways the researchers have tried to define smart cities. So here we can see basically we're focusing on the environment and we are trying to incorporate data, how we can apply it in useful knowledge and we can improve the overall quality of life and the health of the city. Now, another very related term I would like to mention here, that what is this data-driven smart city? This has it has given a rise to a new phenomenon known as data-driven smart cities. That also has given by these researchers, where urban data are mostly collected by the connected IoT devices and analyzed using advanced AI models and techniques. Now, only AI and advancement is not our final goal. Our final goal is a little different, that is the sustainable city. At this moment, we all are talking about sustainability and we try to achieve sustainability in whatever we do. So if I want to, I would like to try define what is a sustainable city, we can see a sustainable city is designed to minimize its environmental impact using resources efficiently and promoting long-term ecological balance. The primary goal is to reduce the consumption of resources like water, energy, and raw materials, and mitigate negative environmental impacts such as pollution and waste. Sustainable cities are designed with a focus on promoting human well-being while ensuring the planet's health for future generations. So here we can see that the key features include renewable energy, where the use of solar, wind, and other renewable sources to power the city, green spaces and biodiversity, so parks, gardens, and green roofs that contribute to air quality, aesthetics, and mental health. Then resource efficient system like sustainable water management, waste cycling, energy management, etc. So these are the key features of a sustainable city. Next, we should think about sustainable smart cities versus smart sustainable cities. These are the other two terminology I found out very frequently used in different literatures. So now what is this sustainable smart cities and smart sustainable cities? Basically, we have two pillars we can see. One is smart city, another is sustainable city. But with the advancement of technology, smart city, what we want, we have to achieve that. But at the same time, how much importance we will give to technology and how much importance will go to, will give to environment, that we have to have a balance into. So sustainable smart cities. So first we will try to discuss sustainable smart cities. That refers to those smart cities, for example, Barcelona, London, Singapore, Helsinki, that are striving to become environmentally sustainable based on integrating data-driven technologies and solutions with green technologies and strategies. On the other hand, what we can see in smart sustainable cities, that refers to those sustainable cities, for example, Stockholm, Copenhagen, Amsterdam, Zurich, that are striving to improve and maintain their contribution to environmental sustainability on the basis of advancing their green technologies and strategies through data-driven technology solutions. So we can see smart city, sustainable city, and then smart sustainable city, sustainable smart city. So nature of smart city also will be there. Sustainable city will also be there. But in which case, which one I will prioritize? Depending on that, we have to take our decision. Here, it is important to note that these examples of cities are known for promoting certain aspects of environmental sustainability, and some of them are both smart and sustainable or sustainable smart. For example, we can see that Stockholm, as a smart sustainable city, aims to become climate positive by 2024 by using data-driven technologies to optimize or improve energy efficiency, pollution, power grids, all these things they want to implement using this. Now, there is an overlap. Now, what is this overlap? The two concepts often overlap, as smart cities can integrate technologies that make urban areas more sustainable. For example, smart grids for energy, smart waste management systems, efficient transport network, all these to contribute a city's sustainability goal. Now we can see the general applications of the smart city. So what are the domains where the smart city should be functional? So we can see, we can start with smart governance. In smart governance, what we can see e-governance, collaborative decision-making policies, citizens' participation. These are the focus of smart governance. Next is smart living and infrastructure. What will come under this? Smart building, smart home, smart education, smart tourism and cultural activities. This will come under smart living and infrastructure. Now, smart mobility and transportation. So, which is actually our focus today. Smart mobility and transformation, what we can see here, private and public traffic management, dynamic routing, smart parking, sustainable mobility, and vehicle sharing. Next is smart economy. In smart economy, what we can see is smart business, e-commerce, smart retail and shopping, peer-to-peer marketplace, peer-to-peer labor service. So then what are the other things are there? That smart industry. Smart industry, what we can see in smart industry. So all the industrial development related activities, we can incorporate technologies to implement in an effective way. Similarly, smart energy management. And another thing is that smart environment. In smart environment, again, what we are seeing, we can see that air quality monitoring, weather monitoring, smart waste management, smart water, all this comes under smart environment. Then another very important aspect is smart healthcare. So all healthcare related issues, for example, smart hospitals, telemedicines, telenursing, e-health robots, healthcare tracking, all these things will come under the smart healthcare. So these are the domains where smart city can be functional. Now let us see smart cities and smart mobility. Now, what is mobility management? Mobility management is generally related to the efficient management of urban transport systems. It requires and uses information and communication system to supervise the transport. These technologies can be used to encourage people's These technologies can be used for remote detection and video surveillance systems to manage traffic flow, pedestrian, and emergency handling. Smart mobility also requires various models of public transport using environment-friendly fuels. Environment protection is the another focus. This is here to promote a green environment. Web-based and remote monitoring are required to understand the public and green area fully. It also requires greater environmental sustainability through better optimization and management of buildings, urban resources, and the community for energy conservation and reduction in harmful emissions. It also focuses on citizen welfare. In citizen welfare, it is actually focusing on human resources that are developed to promote innovation and information technology development using a conductive learning environment. Smart learning system enhances creativity, open-mindedness, and flexibility. Different help centers and strategies are used to explore and encourage people's participation in public matters and solve the problem. It also focuses on economic growth, which is one of the most important focus of smart cities, that economic growth that requires implementing services, production automation, schemes to accelerate work progress, then innovation, entrepreneurship, everything. Now, what are the things required to have smart mobility in the smart cities? Now, in the smart cities, we'll be using ICT for sustainable urban living. Smart mobility will focus on intelligent transport using AI, IoT, and data analytics. Focus on multimodal integration and real-time optimization. Smart infrastructure, connected vehicles, sensors, etc. for the final implementation of the smart mobility system. Now, what are the challenges in the urban mobility? The first challenge we can see the traffic congestion and poor flow management. Another we can see limited infrastructure and parking availability. Data fragmentation among stakeholders. Inefficient public transport planning. Need for real-time and adaptive systems. Now let us see who are the stakeholders. Stakeholders are the government and urban planners, that is for policy and governance, transport authorities, operations and control, then technology providers, AI and IoT platform developers, citizens, data contributors and beneficiaries, academia and researchers for modeling innovative solutions. These are the stakeholders of smart mobility system. Now, we will focus on the main focus of my lecture is use of big data in smart mobility and smart cities, of course. Now, first we will see that what do we mean by big data. Now, big data refers to a massive amount of business data from a wide variety of sources, much of which is available in real time and much of which is uncertain or unpredictable. Now, there are characteristics of big data. We call it V's of big data. Now, in this V's of big data, what we can see, volume, velocity, variety, veracity, value. Earlier, we used to discuss this V's only in three, mainly volume, velocity, and variety. As the time progresses, depending on the increased use and increased volume of data, the number of V's are also increasing, we can say. So let us see that what are these V's. First is volume. This is a massive size of data in terabytes, petabytes, etc. Next is the velocity, speed of data generation and processing in real time. Say, for example, if we consider a case of mobility, say on a road, some accident has taken place, and we need some immediate information to mitigate the difficulties. Now, if the data, whatever is available, is not reaching quickly in time, then that particular problem cannot be solved. So velocity is a very important aspect of big data. Next is variety, multiple formats. What are the formats? Structured, semi-structured, and unstructured. Structured data means what? We have a database system where we can, in a very structured way, we can store our data so that it can be retrieved in an efficient and quicker manner. So there I know exactly if I am storing a particular data, we are storing this data in this terms, or in terms of this attributes. So easily referring to those attributes, we can access those data. Next is semi-structured. Where from this semi-structured data is coming? Semi-structured means some portion will be structured and some portions are not structured. Means unstructured. And next is completely unstructured. Now, what do we mean by this unstructured data? Unstructured data means it is not stored in a very organized way or maintaining a particular format like the data we are storing in database management system. Then what is the source of this unstructured data? So we can see that many times, say for example, I'm taking a review of a particular product. For a particular product, if I am giving a review, the review can be available anywhere. Means suppose in a social media platform, somebody is writing something about that product. And that type of platform also, there are many such platforms. Somebody is writing something in a Twitter, somebody is writing something in a Facebook. There also the nature of review they can give that differs. Say for example, in a Twitter, we write a very small text. We don't elaborate things. So what type of data or what type of information we are giving from Twitter, and it is very short, what type of information people can give, it is a little different from the type of data people are giving when they are writing the same review in a Facebook or any product page where they can give a detailed review. So if I want to, on the basis of that data, if I want to come to a conclusion that what type of product is this, we have to keep in mind that the platform changes. Along with that, in case of Twitter, say a negative type of comment may be more highlighted by the same person when the person is writing the same review in a Facebook. So handling unstructured data is actually very, very challenging. So the semi-structured, as I already mentioned, is a combination of structured as well as unstructured data. Next comes the veracity. That is the trustworthiness, accuracy, and quality of data. Whenever we are going to take any decision, the quality of data matters a lot. If the data is not correct or properly available or incomplete, if it is not complete, then the decision making that we are going to do using that data the decision and quality of the decision will also not be good. So the quality of decision depends on the trustworthiness, accuracy, and the quality of data that we are using in the decision making process. Next comes the value, usefulness of data, ability to generate insights. That is the value. What type of data? Suppose I want to take a decision. So for that, I need some data. So what type of data will be useful for me? That is definitely a concern. Usefulness of data, ability to generate insights is very important to select the data set. Now the variability, changing meaning or context and inconsistent flow. So continuously, it may change the context. Depending on the context, the meaning of the data also may change. That also we have to keep in mind. Next is visualization. Now, what is visualization is one of the most important aspect for which we are doing all this data analytics. Represents data in chart, graph, dashboards, so that it can give a visual impact and we can easily decide or we can easily understand that which data is actually useful for us and which data is performing what way. Next is the validity. data's relevance and appropriateness for the problem. Means for which type of decision, what type of data I need. So that is the validity, relevance, and appropriateness. So these are the V's of big data. Now, next comes the methods of big data collection. What are the methods by which we can collect such a huge amount of data? First is direct collection. We can have the surveys, forms, registrations, purchase details. As I just told you that here we can see the difference between structured and unstructured data. If I am asking or collecting the data, what way I'm collecting the data, that actually plays a very important role to make it what form we will get it in. Means it will come in a structured form or unstructured form, what way. So if we are giving very structured format to collect the data, we'll definitely get structured data. Sorry. Now the direct collection is surveys, form, registration, purchase detail, etc. Then web scraping. What we are doing? Automated extraction from websites. So just now I have already given an example that from different social media website and the social media platforms and different types of websites we can use to collect data. Now, social media monitoring, tracking hashtags, likes, comments, trends, these are also of this category. Now, sensor and IoT devices, smart devices, industrial sensors, wearables, these are also there from which we are getting the data. Now, the transactional systems, banking, retails, and then online payments, all these things are there for giving us the transactional data. Now, the log files and digital traces, server logs, app usage records, system logs, etc. Now, public database or open data. There also we have many organizations who can give us some useful data. So that type of data also we can take from them and can apply into our decision-making process. Then the other type of data we can have, where we can collect from, that is mobile data, that is GPS, app usage, real-time location. These are also the data. Say for example, mobile data, so or the GPS or the real-time location, wherever I am going, my mobile is tracking my location. So I can collect the data that a person is going in which places at what time. So on that basis of that, different type of decision can be taken. And the crowdsourcing is also there, that is voluntary public inputs. Next, we have to see the applications of big data. So this is how we collect the huge amount of data. Now let us see where all we can use this data. The first is direct collection. Okay. So we'll go to challenges of big data. So already we have discussed different applications. So we'll go to challenges of big data. The first is volume and storage. That is a huge size and expensive storage. Data quality or veracity, errors, duplicate, incomplete, or fake data we can collect. So whatever we are collecting, that is it is not guaranteed that all those data will be really useful. Then integration, combining multiple sources and formats. Processing speed, need for real-time analytics, privacy and security, protecting sensitive personal data, cost and infrastructure, high investment in systems and tools. Then skilled workforce, shortage of data scientists and engineers who will do this analytics. Then government and compliance, legal regulations. And then visualization, difficulty in making results clear and meaningful. And then another challenge is the technological change. Tools evolve very quickly, requiring adaptation. We may not get suitable people who can work on this or the technologies to support this. Now, the emerging trends in big data. So what are the emerging trends? We can see AI and machine learning, automatic pattern detection, prediction, and then the real-time analytics, live data processing, for example, urban stock trading, then IoT expansions, then smart homes, smart cities, connected devices, cloud computing and data lakes, scalable storage and raw data management. Then edge computing, local processing, for example, self-driving cars. In case of edge computing, so for self-driving cars, whatever information we need, it should be near to the device. So it should not come from the cloud. There is a difference between cloud computing and edge computing. Cloud computing means it is coming from the, it is to all the data are stored in a remote location, and whatever data we need, we should have an internet connection so that we can get the data from that particular server stored in a stored as a cloud server. But edge computing is that is how it is different from the cloud computing, that here the data is not always coming from the cloud, rather it is located very near to the device which will use it. So in case of self-driving car, so very quick and fast decision is to be taken. So it will take time if we have to take the server, the data from the server. So it is much better that we can take the data from the nearby location. Next is privacy and security. Then encryption, anonymization, blockchain use. These technologies are there which can ensure privacy and security. And then automation, automated cleaning, preparation, and pipelines. So this is basically how we prepare the data and how we can making it ready to fit into a particular model for our data analytics work. Next is predictive and perspective analytics, forecasting and recommending actions. Then blockchain and cryptocurrency, fraud detection, transaction monitoring, then sustainability and green data, efficient resource usage, climate actions. All these are there, which are coming under the emerging trends in big data. Big data can be utilized in so many different ways. Now here we will focus on the big data technologies. There is a separate set of technologies we should mention for big data, because we have already discussed that big data means a huge size. It's not that we can easily store into a database management system and we can, means that the traditional database management system and we can process it. So as the nature of the data is completely different, first of all, it's huge. Next, the structure is also not there in most of the cases. Structured, semi-structured, and unstructured, all type of data are there. Data is there. So we have to have a whole set of separate technologies to handle this data. And also this data has to satisfy different V's that we have discussed only a few minutes back. So what we can see, the Hadoop ecosystem. What is that? HDFL, MapReduce. These are the Yarn, distributed storage and processing. This is there for distributed storage and processing, because traditional database system is not going to help in this case. Next is we can see the Apache Spark. This is for real-time fast as advanced analytics. It is supported by Apache Spark. NoSQL database, then MongoDB, Cassandra, then HBase, all these things are there to support the type of database supported by the big data. Now, data warehouses, structured analytics are there, data lakes are there, raw data storage. So for that also, what we need HDFS, because this type of database system only can give the support for this. Then the cloud platforms are there, AWS is there, Azure, Google Cloud, all these things are there. Then visualization tool, Tableau, Power BI, Data Studio, these are there because of ultimately whatever analytics we do, we need to present in a visual format. So different techniques are there. Now different AI ML framework is also there, that is TensorFlow, PyTorch, Scikit-learn, all these things are there. Then ELT tools are also there, and then stream processing is also there, and blockchain and security tools are also required separately to provide encryption and then tamper-proof systems. So these are the different big data technology, the whole stack we can see of technologies that we need for big data processing. Okay, so now we have already seen for this type of smart cities and urban mobilities, what type of data we need, that is big data, and how we can collect and process it, and what are the technologies. Now data is with us. Next, what we have to do, we have to see data, what type of data analytics are possible. So if we focus on the type of data analytics, we can see descriptive analytics, diagnostic analysis, predictive analytics, and prescriptive analysis. Now, each of them we will discuss one by one with examples. So, the first is descriptive analytics. The descriptive, so all these things, basically how they differ from each other. They differ from each other mainly what type of question they can answer. Okay. So descriptive analytics mainly answer the question, what has happened? So what is the definition? What is descriptive analytics? Descriptive analysis summarizes and visualizes historical data to understand past trends and patterns in urban mobility. So what it is doing? Descriptive analysis summarizes and visualizes historical data. What has happened? That is our question here. So we are focusing on historical data to understand past trends and patterns in the urban mobility. Now, all the examples I have taken from urban mobility only. Now, in smart cities, it answers questions like where and when did traffic congestion occur last week? It is only about looking at historical data. Now, which bus route were most utilized? These are the questions. For example, dashboard showing average traffic speed by zone-wise traffic speed. Heat map of ride sharing demand. Monthly report on metro rider trends. So these are the examples. All these things we are taking from the historical data only. Now, in this particular case, what type of analytics or AI tools we can use? I have mentioned with each of these analytics. So in this case, we can see the techniques we can use is data aggregation, visualization, and statistical summaries. So it is basically we are putting things on, focus on visualization and statistical summaries on the historical data. The next type of analytics, what is this? That is diagnostic analysis. What type of question it will answer? It will answer why did it happen? Earlier we told what happened. Now we are asking what happened? Why did it happen? Sorry. Now what is this? The definition, diagnostic analysis digs deeper into causal relationships, identifying why a mobility issue or traffic event occurred. Now in smart city, it can answer questions as, why did traffic slow down on route A yesterday? What is due to an accident, weather or road? I mean, what is the reason? Whether it's a weather, bad weather, or it is a bad road condition. Now comes the example. Correlating conditions with rainfall data or roadwork updates. These are the useful things that we need. Correlating condition with rainfall. This condition, whether it is related with rainfall or not. So we are trying to figure out. Or what about the whether this condition is related to the road work update? Some road work is there and that's why condition is happening. Now analyzing public transport delays caused by infrastructure issues. Enough road space is not there. So it's a daily situation that in this type of roads congestion happens. Now what type of technique we can use to get insight of diagnostic analytics? The technique we can use that correlation analysis. Just now we have mentioned we are trying to figure it out whether this condition is related to rainfall or not, some road work or not. So we are trying to utilize the correlation analysis. Root cause analysis, data mining, clustering. So these are the techniques we can use to answer the questions in diagnostic analytics. Next comes predictive analytics. What type of question it answers? What is likely to happen? Now we are going to predict something in future. The last two questions were basically on what has happened and why. That has already happened. Now here we are trying to predict. Definition is what? Predictive analysis uses machine learning and statistical models to forecast future mobility patterns or events. So now we are going to talk about the future. What may happen in future. In smart cities, it answers questions such as, where will congestion likely occur in next 30 minutes? This may be a question. What will be the peak demand time for buses tomorrow? So this is again another question. What we are trying to predict, that what is going to happen in next 30 minutes or what is going to happen tomorrow in the future. So now what type of examples? Okay, so examples we can see using real-time GPS data to predict upcoming traffic jams. So that is what we are going to do here. We are forecasting EV charging demand based on usage trends. So if we can estimate what type of demand is going to come in this particular area, it may be in traffic, it may be in e-commerce or in commerce, business, wherever. So it will always keep us in a comfortable position that we can acquire that and we can handle the situation properly. So what type of technique we can use here? The techniques used: time series forecasting, regression, neural network, LSTM models. These are the techniques we are using in predictive analysis. What is actually going to give some answer that what is going to happen in near future or maybe not a very near future. Now, prescriptive analysis, what should we do about it? Means this question is nothing but how can we fix it? How can we handle it? So what is the definition? The definition is prescriptive analytics goes beyond prediction. It recommends optimal action or decisions using AI, optimization and simulation. Here comes this optimization, what we can do, and that too, just not anything in an optimized way. So this is the question, what should we do about it? So in smart city, what type of question it can answer? How can we reroute vehicle to minimize congestion? What is the best timing pattern for traffic light during rush hours? So these are the questions this prescriptive analytics can answer. Means when we are understanding that what type of situation is going to come in future, then it's an obvious question next that we have understood that this is going to happen. Now, how we can fix it up? So that is why we are thinking that way, that how can we reroute vehicles to minimize congestion? Means some vehicle we can reroute so that the very much congested routes can be, will not be overburdened anymore. Now, what is the best timing pattern for traffic lights during the rush hours? Now, example, adaptive traffic signal control using reinforcement learning. This is one application, example application. Dynamic route recommendation for public transport or ride sharing. So we can give this type of recommendations. So here basically we can give some recommendations and we can give some techniques to handle it. So adaptive traffic signal control we can do, and we can also give some recommendation based on the analysis we have done. So what type of technique we can use here? Optimization models. Optimization models plays a very important role in this case. Other techniques very popularly used as reinforcement learning, simulation, decision automation. These are the different techniques we can see how we can take these things into account to suggest some fixes of our predicted problems. So here we can see different types of analysis we have seen, and some example we have seen. So basically what we are then focusing on, the role of big data in mobility. Basically, what are the focus area then? Provides evidence-based decision making. Evidence will be there, and accordingly we will do the decision making. Enables predictive and prescriptive analysis depending on a various situation. Some of the examples I have given. Integrates multiple data streams for optimization. In optimization, we have to remember that whatever, if I get enough data, definitely the optimization decision, whatever we will get from optimization will be better. And then supports real-time traffic management and planning. And drives innovation in public transport services. So these are the focus area where big data analytics can give a big boost to the mobility, or we can say the smart mobility in smart cities. Now here we will see sources of mobility data, where from we can get it. The IoT sensors and smart traffic lights. Next is GPS data from vehicle and smartphones. Public transport, smart cards and ticketing systems. Social media and crowdsourced feedback. Environmental and weather data integration. So these are the places where we can collect data, particularly for smart mobility. Now, what type of AI and machine learning applications we can apply here? Now, we have just now described the predictive analytics for congestion and travel demand. We can use reinforcement learning as an AI technique for adaptive traffic signals. Then clustering for route optimization, deep learning for anomaly and pattern detection, computer vision for vehicle and pedestrian monitoring. So we can see all these types of things. The points mentioned here are incorporating the analytics as well as data analytics as well as AI techniques for solving our problems in smart cities. Now we will look into some case studies. So this particular case study is actually taken from this paper, again from BDB and all in 2020. They have done a very nice comparison between the two cities, London and Barcelona. So before going to that particular comparison, we'll see what is a type of infrastructure they are telling which is required for data-driven sustainable smart cities. The name of the paper is Conceptual Framework for Data-Driven Smart Cities. So if anybody is interested, you can go through this particular paper to get more details about it. Next is smart cities. The first comes the smart cities in this particular architecture. From the smart city, what we are getting? We are getting the data-driven city that we have already discussed. Smart city, now it is collecting huge data. We are talking about the data-driven city. Now in data-driven city, what we can see, this is the infrastructure, then the data sources, horizontal information system, data-driven applications. So all are coming, the features of, we can say, the data-driven city. So infrastructure, data source, horizontal information system, data-driven application. On the other side, what is there? Urban analytical center. Okay, an urban analytical center, then urban dashboard, then the innovation lab or research center, strategic planning office. All these are there in a data-driven city. In the data-driven city, in one hand, we can see all these things are there. And in another place, we can see these things are also there. Now, from here, we can see this infrastructure, data warehouse, horizontal information system, data-driven applications. We can see that operations, functions, services, strategies, policies, these are actually functional for which the data we are getting from here. And here what we are getting, that urban analytical center, urban dashboard, research lab center, strategic planning, they are mainly focusing on sustainability, efficiency, resilience, equity, and quality of life. All these two things are talking to each other, exchanging data to each other, and finally they are giving the output for the data-driven sustainable smart cities. Now let us see that in their comparison, what they have given in London versus Barcelona. This study shows that these cities have a high level of development of applied data-driven technologies. but they slightly differ in the level of implementation of such technologies in different city systems and domains with respect to sustainability areas. So basically what is shown in this studies, this study basically focuses a high level of development of applied data-driven technology. Both the cities have applied these data-driven technologies, but there are certain differences. Means what type of technologies London has focused and what type of technologies Barcelona has focused. In the level of implementation of such technologies in different city systems and domains with respect to sustainability areas. They also moderately differ in the degree of their readiness as to the ability and development level of the competence and infrastructure needed to generate, transmit, process, and analyze large masses of data to extract useful information for enhanced decision making and deep insights pertaining to urban operational functioning, management, and planning relation to sustainability. So see, both these cities, they have the target for smart cities, but both of them are highlighting on sustainability as well. And as we have seen in the earlier slide, that this data-driven sustainable smart city. So their target is not only, this comes in the category we have already discussed at the beginning of our in this presentation, that what is a sustainable smart city and what is a smart sustainable city. So both these things has been taken in this particular study is sustainable smart city. It means they are using analytics and AI techniques to make the city smart, but their main focus is sustainable. That's why it's a sustainable smart city. Both these cities are sustainable smart cities. So, but how they have applied the sustainability, there are certain differences. Let us see that. London takes the lead as regards the ICT infrastructure and data sources, where Barcelona has the best practices in data-oriented competence, notably horizontal information platforms, operation centers, dashboards, training programs, and educational institutes, innovation labs, research centers, and strategic planning offices. Okay, so Barcelona has the basic focus on all different areas of the application. Horizontal information platform, operations center, dashboard focuses analytics, training program, educational institute, all these types of things they have taken into consideration, making their solution for sustainable and smart cities. This research enhances the scholarly community's current understanding of the new phenomenon of the data-driven city with respect to the untapped synergistic potential of the integration of smart urbanism and sustainable urbanism for advancing sustainability in the light of emerging paradigm of big data computing. So here we can see one thing, that both the cities are using ICT, means information and communication technology. So there are also a lot of information we are using. But where we are focusing, that there actually London differs from Barcelona. You can see Barcelona has used it in various areas of their life. And this paper, if somebody is interested, they can also go through this paper. Many very interesting inputs are available here, that how in different areas they have focused, both the cities. They have focused, and along with smart city, how they have incorporated sustainability. Now, here we can see, this is about London and Barcelona. Many other cities are also there. Say, for example, Singapore also is there, where they have also implemented different types of traffic lighting and many other mobility related things they have also done, but their focus is mainly smart city and not a their focus is sustainability. Everywhere nowadays, everywhere it is being focused, but their focus is smart cities. But where is in case of London and Barcelona, they are focusing on sustainable smart cities. Now, I have seen what is there in India also. So, in India, what we can see that implementation, there are implementation under smart city mission. Some some particular cities we can see Bangalore, Pune, Delhi. They are mainly focusing on deployment of adaptive traffic system and surveillance of surveillance of their AI-driven route suggestion in public transport is there. Integration of GIS for real-time tracking and analytics is there. As per the current situation, government have identified 100 smart cities in India for final development. And as per the available information, only 18 out of 100 cities we can see maybe which are almost uh, in the way of uh, reaching the target. So these are some case studies. Now we can see challenges. Now, what are the challenges and barriers? Data privacy and user consent issues. See, when we are talking about big data means actually, as I was telling, that everything, nothing we have actually in private nowadays. The situation is like that. Data privacy and user consent has become a very big issues in the present moment. As I was telling you, few minutes back that my mobile can track the location and many other things. Means it knows exactly what time, where. If the location is on, it can track that at what time where I go. So it can be used to benefit me as well, and it can I mean, it can be used to put me in problem as well. So why the data privacy means privacy is not there. So everything is known because of these type of devices. So this is definitely a matter of concern. User consent issues, because I may not be very much comfortable to share all my movements with this type of systems. But here we cannot do anything. Means consent issues and data privacy issues, it's a major concern. Then integration of heterogeneous data systems. It is another very important issue. Heterogeneous data systems means it's a matter of interoperability. Something, whatever is I'm using it in this particular platform, and another thing is there in another way it is stored in the other platform. Now the question is how these two platform will integrate, how these two platform will interact, what would be the language, how can one's data can be read by the other system. Otherwise, if you just think about the cloud environment, even in the cloud environment also, data is stored in different servers, different operating system they are managing. But even after that, certain technology has been implemented so that they can seamlessly interact with one another. If the seamless interaction is not there, then it will be difficult for integration. I mean, integration and getting the real-time data wherever and whenever it is required. Say, for example, I will give one example from here, integration of heterogeneous data system. This is mainly focuses on interoperability. From data analytics point of view, say a recommendation system, or somewhere I want to understand what is the feedback of this particular particular product. Just now I mentioned that the same person can give review in of a particular product in a Twitter, and the same person is writing a review, can write a review in detail in some other platform, maybe a product review platform, maybe some other type of platform, say social media platform, maybe for Facebook, maybe. It has been found out that whenever it has been found out in the research that whenever we are trying to analyze the data from Twitter, mostly we get negative results because their space to mention something is very less. Now, if we are taking data from different sources, where means they are highlighting only the issues, most of the cases. But when the same person is given the opportunity to write it in details, then they are mentioning many things which they like. So whenever I'm taking data from different sources and I'm trying to figure out whether the review is positive or negative or neutral, there also we have to think about the different platform are there and different platform has their own advantage and limitation. So keeping that, so it should not be biased on Twitter. It should not be biased on Facebook. So we have to find out the ground where all these limitations and advantages should be kept into mind and a proper analysis is done. Next is cost of infrastructure and maintenance. Cost of infrastructure and maintenance is definitely is a very big concern because cost of infrastructure and maintenance is again many of the companies when they are installing different types of infrastructure, then it's a definitely the how much cost they can bear. It is a major concern, and many companies have found out that yes, if they can migrate to cloud, their cost of infrastructure installation and maintenance will be much less. I mean, very cost effective. So that challenge can be handled in that way as well. Now, the lack of standardization and interoperability. Just now I was mentioning that standardization is not there. Standardization is not there means how this particular data will be stored here, how the standard data will be stored there, how these two systems will interact. If they are not interoperable, they cannot talk to each other, and then overall data network is going to fail. Say, for example, you are stuck in a system and where you want to know that in which direction your vehicle you want to reroute. So if the immediate information is not coming because different systems, actually they have the infrastructural different, the type of, the way they operate is different. So they are not being able to interact to one another. In that case, what will happen? You will not be able to get the required data on time. At the point of need, you will not get it. So you will not be able to take real-time decisions. So lack of standardization and interoperability. Interoperability is a huge issue on which the current research should focus on. And now the public acceptance and trust in automation. Yes, so now in this case, what we are doing, say overall automation, many places we are using, say automatic, right from automatic vehicle to many other places wherever the automation is in place, that trust should be there. So this is another very important research opportunity at this moment, how to make trust, how to bring trust into this type of areas. Say for example, now, so all different AI techniques I have already mentioned. Say, for example, machine learning and deep learning techniques are there. They are predicting something. It can be a route, maybe a route prediction. It can be a disease prediction. Different types of predictions is being done into our smart cities using this AI and ML and deep learning models. But the AI, ML, the ML and deep learning models, they are simply depending on their structure, the way they operate, they are just predicting that, yes, this is this disease, or at this moment, you should go through this route. But you may have a question in your mind whether this prediction is correct or not. So there, a huge research opportunity is there to find out how trust can be given by, again, AI itself. So there, the explainability models are coming into the scene. So what these explainability models are doing? They are telling, so earlier this deep learning models, we call it a black box model. Black box type model means it will not tell you how the decision making it has done. Means it is simply telling, say for example, this is an elephant, that's all. But it will not tell you why it inferred that it is an elephant. But the explainability model can actually incorporate trust and reliability into this type of things. What is that? We can see that we can tell that yes, it has trunks, it has tail. So I am telling that it is that an elephant. It can add this. So this is the explainability model. This is also a very huge research opportunity in different area, in medical diagnosis. It may be route prediction, smart city applications, smart mobility application. Everywhere we can do this. Now comes the ethical and legal consideration. Transparency and accountability in AI decisions. So transparency and accountability, just now I was mentioning that these ethical issues will be there where the transparency and accountability is required. And next we can see the data protection and compliance with the local regulations. Data compliance is required and data protection, definitely it's another very big issue. And then bias in AI algorithms affecting decision fairness. Bias in AI algorithm affecting decision fairness means we can say that whenever a decision making we are doing, some biases are always there. So how we can get rid of those biases so that the decision it is giving, it is fair and it is acceptable and reliable. Now, public communication and citizen engagement. Public communication and citizen engagement means whatever we are doing, if we don't have people with us, so we cannot actually survive. So the data that we are collecting from the citizen only. So we have already discussed this in the slide where we are discussing about the stakeholders. They are the people who are giving the data on which we are doing the whole system. We are building the whole system. So that public communication, why we need this data is because people are scared to share their data. So that should not be there. So everybody should understand why they are giving this and how it can benefit their life. So whatever project we are doing, if we can engage people into it, it always gives the better success of that particular project. So public communication and citizen engagement is also a very important issue. Now let us see what are the future trends in data-driven mobility. Integration of AI with digital twins model. What is a digital twin? Digital twin means, say a physical system is there and there is a digital system exactly to simulate that there is a digital model. And we can see how this digital twin, we are integrating these two systems are communicating and we are coming up with a better model. So digital twins are nothing but a physical model and the same data-driven model with that of that particular physical model. So now autonomous vehicles and connected infrastructure, federated learning for privacy preserving analytics. These are all the new techniques. These are all the new techniques that we are utilizing to improve our overall system. Then 6G and IoT integration for ultra low latency systems. And then behavioral data modeling and adaptive planning. Behavioral data modeling means we have to understand how people, how the system behaves. It may be people live with the overall system and then how the system can be, say the adaptive path planning of a robot. Adaptive path planning. So say we are not fixing up a particular route. Depending on the traffic condition and other sources, other reasons, that we have achieved from different sources, the robot can find out its path or change its path in an adaptive way. So behavioral data modeling, adaptive planning, these are the future trends we can see into this particular area. Mobilities and smart cities. Now, in conclusion and takeaways, what we can see, the big data and AI are central to modern mobility planning in smart city implementation. So interdisciplinary collaboration is essential for success. Otherwise, so we can see that robot is there, healthcare is there, so many different things are there. If the interdisciplinary research is not in place, we will not be able to get the appropriate success. Need for policy, ethics, and technological synergy should be there. Focus on scalable, secure, and sustainable solutions should be there. So these are the, this is how we can conclude this lecture, and we can see that these are some of the references that I have used. Many references I have used, only some of them I have mentioned here. So to prepare this presentation. Okay, so thank you. So if you have any question, you can tell.
Thank you, ma'am.
If anyone want to ask anything, please ask.
If anyone want to ask
If anyone
anything, yes.
want to ask,
I think no one going to ask.
Okay then.
I think no one want to ask. Thank you very much, madam.
Okay. Thank you, sir.
Anyone want to ask? Please ask.
Anyone want to ask, please ask.
Okay, madam. Thank you very much. You have taken one long.
Okay, madam. Thank you very much.
Okay then. Thank you,
Okay,
everybody.
madam.
Thank you for inviting me for this lecture, and congratulations to all the organizers to organize such a
Thank you.
relevant and timely topic for FDP. Thank you all. Okay then.
Thank you. Thank you.
Yeah. I can leave the
Thank you.
meeting.
Thank you.
Yeah. I can leave the meeting.
Yes,
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 yes.
yes.
Okay. Thank you so much.
See, our second session will start at 7:30 after 10 minutes. So please join after 10 minutes.
Hello, Murugan sir. Are you there? Hello, sir. Am I audible, sir? Rahul sir, am I audible?
Yes, sir. Audible. Sir.
Actually, sir had a comment. Hello, Murugan sir. Sir, you audible or not? I think not audible, no?
Sir, you are audible.
Sir, I. Sir, accept.
আগে আমি তো কিছুই করিনি।
Yeah, good evening, Deepak sir. Can you hear me?
Sir, good evening, sir. Good evening, sir. Good evening.
Yeah, good evening, Sengupta ma'am. Greetings to
Good
you.
evening, sir. Thank you, sir, for your support.
Once camera picture
For
the
every
Always,
FTP, you are
always.
supporting us.
Sir, actually all will join within 3 minutes.
Sure, sure, sure.
No.
Divak sir, can you able to see my screen?
Yes, sir.
No, sir, it's come.
Okay, okay, ma'am.
Yes, sir. Yes, sir. Yes, sir. After 2 to 4 minutes.
Sir, we can start now. Slowly they will join, sir, within 2 3 minutes. All will join.
Okay, sir,
Murugan, sir.
fine. Okay, okay, go ahead, sir.
Sir, start.
Welcome everybody. This is Rahul. Welcome to the Faculty Development Program on Applications of Communication, Signal Processing, Robotics for Smart Cities, organized by Department of ECE and sponsored by Atal Academy. So the topic of today's lecture is disorder using CWT and deep learning algorithm from electroencephalogram. And the expert speaker is Dr. R. Murugan, sir. Before I invite sir to commence the session, I would like to have a brief bio sketch of the eminent speaker. Dr. R. Murugan was born in Ramanathapuram, Tamil Nadu, India. He received the BE degree in Electronics and Communication Engineering, the ME degree in Embedded System Technologies from Anna University, Chennai, Tamil Nadu, and the PhD degree from Information and Communication Engineering Center for Research, Anna University, Chennai, Tamil Nadu. He worked as an assistant professor in the Department of Electronics and Communication Engineering, Ali Muhammad Saleh College of Engineering, Chennai, from August to December 2017. He worked as an assistant professor in the Department of Electronics and Communication Engineering, St. Peter's Engineering College, Hyderabad, from 8 January 2018 to 30th May 2018. He is working as assistant professor in the Department of Electronics and Communication Engineering, National Institute of Technology, Silchar, Assam, India since 15th June 2018. He has published more than 70 research articles in various international, national journals and conferences as of date. He is the fellow of IT, an active member of IEEE, and a life member of Indian Society for Technical Education, India. He is the chair of IEEE Signal Processing Society of Joint Chapter of IEEE Kolkata section of IEEE Silchar subsection. He is the co-chair of Student Activities Committee of IEEE Silchar subsection. He has received an Outstanding Reviewer Award from Biomedical Signal Processing Control Elsevier Journal and also received the Best Paper Award from various flagship international conferences. He is the invited reviewer of many journals, which includes IEEE Transactions and Medical Imaging, IEEE Internet of Things, and Journal of IEEE Access, along with the Biomedical Signal Processing and Control. He is the recipient of Young Researcher Fellowship from GST served Government of India for the project, a nationwide study on retinal detachment in India, with emphasis on the risk of the fellow eye profundus images using deep learning. He is the recipient of NVIDIA Academic Hardware Grant Program for the project diagnosis of retinal pathologies using deep learning. He has published more than 30 journal publications, 35 conference proceedings, 2 books, 11 book chapters, and 4 patents in his credit. His area of interest, which includes biomedical signal and image processing, medical imaging, retinal image analysis, computer vision, pattern recognition, machine learning, and deep learning. With this introduction, I would like to request Murugan sir to commence the session. Over to you, sir.
Yeah, thank you, Rahul ji,
Thank you,
for
sir.
a long introduction. Thank you so much.
Thank you, sir.
Okay, so very good evening once again to all of you. The today topic which has given to me is very interesting topic. So I just due to the bandwidth issue, so just stopping my video, but hope my audio will be very clear to you. So the today topic what I am going to present to you is that the classification of epileptic seizures disorder using CWT, that's nothing but continuous wavelet transform, and deep learning algorithms from electroencephalograms. So let me brief describe about this topic. We all known the term is very familiar, like say encephalogram, like we used to call in signal processing called EEG signals, like how we acquire the ECG signals, for the analysis of our heart, human heart. So which we need to screen with ECG signal. In the same way, if you want to check your, the activity of your human brain, so that we need to like acquire with these signals, electroencephalogram. We have EEG machines in nature. So through the EEG machine, that particular signal has been acquired from the human. Then, the other term which I like to describe to you is that epileptic seizures. What is mean by epileptic seizures? Say, like in biomedical engineering, this term is very common. So what is this one? So it is the brain disorder. So if you want to define exactly what is mean by epileptic disorders is like it is a sudden and short episode of abnormal electrical activity in the human brain. Okay, so what happened, due to this disorder, in some time or in some portions, so what happened, there are, the abnormal activity may happen in a short span of time. So this is the nature of this particular disorder, epileptic seizures. Okay, so one is signal processing, like how EEG, I mean the EEG, and the epileptic seizure is the biomedical, disease. I mean, in terms of it is a disease, and how actually the engineering is playing here. Like in epileptic seizures, like there are various mechanisms that we need to identify or classify whether the particular person is having the seizures or not. And again, if the particular patient is having a seizures, then what stage it is. So in this case, like, we need to play a engineering and technology for classifying this particular disorder. So how we actually, classifying this disease through the techniques like say CWT, which is nothing but continuous wavelet transform. Everybody knows this term. And not only this way wavelet, but also we are utilizing a deep learning approach for a classification. Okay, so this is the whole description of this today topic, so that you can able to understand, what actually we are going to, discuss in this today lecture. So if you look at in this context, so I will directly going into, the introductory part of this one, the epileptic seizures disorder detection. So if any researchers like us or any technologists like us, like before getting into the engineering part, we should always learn in the biomedical part. So whenever we want to learn the biomedical part, so of course we need to learn the biomedical physics of the particular disease or disorder, so that like we can understand the research problem, how the engineers or technologists can able to contribute. In this case, like say, if you want to define in terms of biomedical, like say, as I said, it is abnormal activity in the human brain. So of course we know what is a brain, like no need to define, everybody is know like. So the brain is one of the largest and complex organs in the human body, and it coordinates most of the brain activities, which we know. So like in the brain, like have a skull and we have 1,000 millions of neurons, and of course the neurons will be messengers to the brain, and of course it may be sending to what we have to do, right? The whole universe is running from this, the messengers, how neurons can into the brain, sent into the brain. So this is a very common understanding of the biomedical, what is brain. Now, this slide is very important, interesting for you. Like in a typical, the brain, our human brain, is responsible for many functions, different functions. Say our human brain is consist of, many parts, which include like motor control, and of course, touch and pressure, and which part is actually, helpful to observe the taste and the body awareness, language, reading, vision, coordination, many things like even starting from smell, speech, hearing, facial recognition. So all these, the typical human brain is responsible for all type of, the functions. So in like, if something happened in the human brain, what happened? So maybe some functions, maybe the disorder will consist as a disorder. So in this case, like, if you look at the anatomy of the human brain, we have a different lobe, frontal lobe, partial lobe. The color will indicate way better than this, then temporal lobe, occipital lobe, cerebral lobe. So many things which we also learn in somewhere in our school studies, or maybe in somewhere in our engineering textbooks. So here, so the takeaway point from this anatomy of the human brain is that, so the brain is, having n number of responsibility to make it functions normal. Now, coming to a very interesting term, especially in biomedical engineering, electroencephalogram. We simply call it as EEG. So what is this EEG? Like say, as we have seen before, the human brain. So if you want to test your human brain activity, so what way we can able to do? So we need to, acquire the EEG signal of the brain. And based on the signal, like we need to observe whether the particular, like the brain is in normal or it is in abnormal. Okay. So the brain is not only for only a particular disease, what we are going to discuss today, but also it is responsible for other as well. So in this case, like say, if you want to, especially detect or diagnose this epileptic seizure disorder, so we need to set some specific band of the EEG signals. So that particular, the range value will helpful to find the epileptic seizure disorder. Okay, so this is a very basic understanding about electroencephalogram. So now coming into, as I said, there are different range of, the frequencies in EEG signals. So in this case, suppose in a normal EEG signals divided into, different band, like say, gamma, beta, alpha, theta, and delta. Okay, so different ranges. So the range of frequency is also given in this, the typical signals. Like if it is the gamma, what is the range, and it is the delta, what is the range. So the thing is that, like say, in every band of frequency, like it is predefined, by the medical community. So here the point is that, I mean, with respect to the band, and suppose if you to set the frequency of the particular, range in the EEG machine, so we can able to acquire the corresponding EEG signals to test the, activity of the brain. So this is a very, interesting physics behind in this EEG band. Okay, now coming to the interesting engineering point of view is that how the EEG signal is acquired, of course, the brain. So in the, in any lab, or if you go for any radiological department, any of the hospital, like say we can able to see the EEG machine. So in the EEG machine, like, we have a multiple electrode. Okay, so in if you have a 12 electrode, we have, 24 electrode, even 32 electrode. So different electrode systems are available. So this electrode, like, it should be fixed into the human brain. Okay, if you look at the skull, and there is the, in the procedure, so how we have to fix the electrode, it may be, suppose it may be a 22 10 to 20 systems. So the standard, it says that where we have to fix the particular electrode in the human brain. So accordingly, if it is a 24 channel or 32 channel, or how many channels which you have, so based on the standard, like we need to fix the electrode in the human brain. Accordingly, we need to observe the particular frequency, then through the frequency, so we can able to diagnosis, or, the what process that we need to go, and what engineering actually it is playing here. So everything that we need to understand after acquiring the electrical, the activity, or the electrical signal, or the EEG signals from the brain. So this is the very typical process that which will be involved in. Okay, so two fundamental terms which we discussed. So now if you are coming into the seizures, or epileptic seizures, like this, you can define these two terms even separately also, or in combined also. So if you look at the seizures, like the, there are electrical activity in the brain, or in most of the time, the seizures, the central nerve systems, like, the motor control, that will be affect. And if it is epilepsy, it's also a abnormal and spontaneous the abnormal activity. It is affecting the central nervous system. So when it is combined these together, epileptic seizures, so that the central nervous systems that totally affect, and it will be sudden change in the human brain. So in some certain amount of time, I mean the memory, or like the things which will be disturbed, okay, to the brain. The brain is basically disturbed. So this is we like like if I mean define this seizures or epilepsy, or you can even it is an epileptic seizures. So this is the disease, like it's a very common language which you can see. If it is coming into the seizures or epilepsy, like they have a different category of even epilepsy. So one is the partial and another one is a generalized. So in partial, even though there are three more categories: simple partial seizures, complex, and also secondary generalized. The same way, generalized seizure, we have multiple types: tonic, clonic. There are multiple, which will be available, but it may be a very, very deep understanding about the biology of the particular seizures. Here, what point which I like to highlight to the audience is that, like, there are different types of epilepsy, and of course, in between, we have different grading mechanisms. Yeah. So here, the problem comes is that, like, say, we are acquiring a EEG signal. So through the EEG signal, the frequency band, which we are, used for diagnosis of this seizure disorder. But even in between, there are multiple number of seizures and epilepsy. So, like the manual screening of all these type of, the seizures, epilepsy, it is a very, very challenging task. Like then only, that is why, so what we actually looking into the engineering part, we want to go for some kind of automatic approach or automatic algorithm development. So we can ultimately diagnose this particular disorder effectively and maybe in short span of time. So in addition, if it is abnormal activity, so that we can able to consult a particular clinicians to follow, and then we can start the medical treatment and all. So that's why actually this particular problem is motivating to the researchers like us, and we'll look into this. Now, so the whole biological part which have been discussed to you, now we'll getting into the technological perspective. Of course, this disorder and EEG and whole brain systems is very common. So this engineering problem is like thing many of the researchers actually throughout the globe actually they are contributing. So in terms of the contributions, many publications even you can able to find, but still there is the scope to groom this particular research problem, because with respect to many factor, this is also one of the evergreen problem in research, because say we need a multiple amount of data, and what EEG, how many number of channels of EEG medicine we have followed to acquire this, and what metrics which basically the algorithm is actually providing. So in many this criteria will generally motivate the researcher always to do the betterment or improvement in the existing problem. So in this case, if you look at the publications which is already published, and there are multiple number of gaps, the research gap is available. And if you look at this case, like say in the large volume of the researcher, they are utilizing single channel EEG signals. So if you use a single channel EEG signal, what happens? The predictions may not accurate. This is one kind of gap which we can take it from the literature. And in another gap is that most of the studies actually they are addressing only the binary classification, whether the people are having seizures or not having. But still, the supplying or producing the highest performance metrics is also a still challenge in binary class. That's why most of the people are attempting in binary, but still we need to go for multi-class problem in that particular context. So it is a gap. And the another gap which we can say is that during the acquisition process, there are different recording mechanisms which we need to follow of the human brain. I mean the activity. So here what happened? There are different the tools, different softwares which we are using to collect this different the recording and what sampling frequency that they are following during the acquisitions, like many factor. So the formation of EEG signals, so that will also a challenge here. Okay, so again, coming into the performance metrics, so most of the studies, they will supply only accuracy. But if you look at in biomedical engineering, accuracy is not only a metric, but also we require some other important metric. Then only the clinicians can effectively diagnose this disease. So the metrics like F1 score, precision, sensitivity, specificity, and all. So in other ways that like in most of the signals, of course, the signal processing approach, it is a one-dimensional signals. And the processing one-dimensional signals is very, very challenging by this all the technology, what we are having, machine learning, deep learning and all. And so we need to follow some of the two-dimensional signals and how the one-dimensional we are converting from one-dimensional into two-dimensional signals. So that kind of engineering approach that we need to apply so that we can able to use all this the the deep learning and other graph neural network or any of the neural network that can be applicable. So these are the very typical gap that we have understood from the long literature. So now coming into the main part of the stating the problem. So here, for identifying this particular epileptic disorder, we require an expert neurologist. So for example, like if the getting of neurologist is also a very, very challenging, as you know. Like say, for example, in the, if in the very rural background or maybe in the, far away from the main stream of the country, like if it is look at the Northeast and other, places, the neurologists are very, very limited. So but even for getting experienced neurologists, it's also a challenging task, right? So why we use an expert neurologist in this case, so because it is a very, very sensitive signal, the EEG signals. So from the EEG signal, we need to study, we need to identify what type of, the disorders they have, seizures they have. So if you have an expert neurologist, so they can, completely screen the signal, then that finally they can able to find out what category they have. So, but if you look at in this history, very limited expert neurologists are available. And of course, even if you have a very limited experience in the neurologist and, identifying this disease is very, very challenge. And also the accurate classification is also another challenge. So in that way, actually, the problem is more getting to us and to carry out some of the research outcome in this particular disorder. Now, coming to while understanding the statement of the problem. So whenever which you want to implement this particular disorder in the technology, so primarily we require data, right? So if you look at this epileptic seizure disorder, there are some publicly available data set which is available, but this data set is actually well defined and well validated data set. And throughout the globe, the people are using this particular data set. So this data set was created by University of Bern in the Department of Epidemiology. And this particular data set is have a 10 to 20 international electrode system, and have a 5 sets of 100 EEG signals, set of EEG signals. And if it is look at this whole recording, they use 128 channels. And the sets that have A to E, and also the specific durations, and the samples which have been acquired. So there are different sets of 5 sets which we have been having this particular band data set. This data set is consist of, like, say, for example, the A, which will indicate the corresponding band also, Z. So the A, which is indicate the normal subject with the eyes are open. This is a condition that I have to acquire the EG. And second set is that it is a normal subject only, but the eye has to be closed. Then the third category is like, the seizures-free recording from the patients with epilepsy, the recording uptime. So from the opposite of the epidemic zone. And the D is like, the seizure-free recording, that again, the patients having this, the epilepsy zone. And the E of S recording is having with the epilepsy and showing the seizure activity in the brain. So what this condition is, generally describing to the audience is that, so whenever we are requiring the EEG signals, so this type of, the conditions that we need to follow to acquire it. But especially for this particular data set, this is publicly available data set. So this data set is basically given these conditions. And apart from that, we have a different data set that we also used for some other work, like even IIT Delhi, we have one data set that is also publicly available. So like, but the data set is very, very limited, it seems. So if you want to, use then in a large number of data, of course, the University of Bern is one, the ultimate destination of, collecting the multiple recordings in this. So here what, while understanding all this, the data set and all, what we have done, like in our research group, so up to what we have discussed, this is up to the data set. It is the known information to all of you. But during this particular faculty development program, I'm just summarizing to you. So this is the problem. There is a research problem. So you can carry out this problem. From this particular slide onwards, so here, what actually we are doing with this particular data set, and how we actually, the classifying the particular seizure disorder. This we can start from this particular slide. So it's a complete the understanding approach. So now, like as I said, the EEG signals, what we are acquiring, it is a one-dimensional signals, right? So if you have taken the raw one-dimensional signals into any of the machine learning approach, and extracting feature from the one-dimensional signals, it's very, very challenging, right? Because the network is having a huge responsibility, and it is, all networks are very high-end network, And if you are applying a one-dimensional signals, then what will happen? So even the acquisition itself, the particular network is missing a lot of features. So that's why we have a thought of like, converting from this one-dimensional signals into two-dimensional, that two-dimensional, which is called actually time frequency signals. So here what happens is that for the initial understanding about the band data set, we have considered two signals, set of signals. One is Z and another one is S. And this, signals, we have applied, we have, used the different, different wavelet transforms to, find the scalogram, the time frequency signals of the scalogram. So here, what happened? We have applied multiple, the approaches. Then what happens is that now, if you look at this one, like the scaleogram, that you can able to see different colors and the different band, so that ultimately it will help us to do effective feature extraction process. So here I have given some of the the scaleogram image of different wavelet, like say Morselet, Mexican hat, and derivative of Gaussian, Paul, all different wavelet. We have tried different other wavelet also. Say for example, we have tried Haar wavelet and other things, but here in terms of performance wise, so those wavelets are not providing a good metric. That's why we discarded those, the scaleogram image. So which I mean the transform is given a good result. So here actually I'm just keeping here to understand how the features has been extracted. Okay, so in most of the traditional approaches, like say if you use either it can be machine learning approach or any deep learning approach for classification. So here if you use the machine learning, you need to do like say the conventional feature extraction process, right? So here we have tried even machine learning, and also in terms of this, the scaleogram, the machine learning is not even performing better, but still we have a large amount of data in the Ben data set. So we have also used deep learning. So before that, applying into the feature extraction, we have done the pre-processing with the help of this wavelet transforms. So this is one of the pre-processing steps in this. So once the pre-processed data is, ready, what happened? So we have a huge volume of data. So it ultimately helpful, to do the effective feature extraction by the deep neural networks. So that way, actually, we actually did this, the pre-processing steps. Now, this slide maybe given you a clear overview how actually the time frequency representation is, able to visualize from the one-dimensional signals. If you look at the first set of figure, like, we have, the band frequency and also like the different samples and with the amplitude. And the same signal, if you look at in the time frequency representation, if you see, it is, time and also the different scale. And here we have only two scale which are considering Z and S. So in that way, what you can see here, the first one is the Z is in the class 0 and the class 1 is S basically. So what we are converting from one dimensional to two dimensional, so that we can able to effectively utilize all this, the technology like deep learning into this particular case. So in this case, what happened, like, we have formulated one workflow to classify the two class problem. One is the S is epileptic seizures and Z is the non-epileptic seizures. And here the workflow is going like this. Say, for example, if you look at the raw data set which we are having, and in the time frequency signal, and from the time frequency raw signal, we are utilizing the continuous wavelet transform. So this continuous wavelet transform is actually converted with the help of continuous wavelet transform, which will be converted into time frequency image. So this image, which you can, generated a large volume of data with the different data sets, different wavelet. Then after that, which we are converting, splitting the data. So, 70% from the training and 30% for the testing. Okay. So here, the point is that once our training data is ready, so we need to use the deep neural network. So here what happens is that we have tried many, even pre-trained networks, many pre-trained networks. And of course, finally, while performing all these experiments, we have, the VGG19 pre-trained network is given some very good performance metrics, especially for this time frequency scale image. So The other advantage is that if you use the ResNet 50 and other high-end deep neural networks, what happens is that, like, there are required a huge, the infrastructural facility, like we required some workstations and kind of thing, so that we can able to, train the data effectively. So here, our approach is that to look at a lightweight deep neural network. That is also one of the motivation from this particular statement. The reason is that if your network is the bulky network, what happened? Again, it is coming into the practical issue in the implementation part, right? So if you are going for any implement into in any cloud platform, maybe for the telemedicine application, so that we always actually looking into the lightweight neural network. So that way, the development of lightweight neural network is also is one of the evergreen research problem in recent time. That's why we are looking into the other lightweight network like GhostNet, many networks which is available, even mobile net. So ultimately, this VGG19 is actually given a very good metric for this case. That's why we have selected this particular network. So through the VGG19, the network is trained and we can test this network through the test data set, and finally we can able to classify whether they have epileptic or they don't have epileptic seizures. So this way, this workflow is given you the direction of how we can able to implement this classification problem. So this one, the last February, I have presented these works in the 17th International Conference on Knowledge and Smart Technology in Thailand. So last February, I presented this work on behalf of my PhD scholar. Now, coming to the result part of this particular data, this workflow. So we have tested different network, as I said, even Inception V3, Efficient Net V2B0, even AlexNet. And if you look at in terms of testing, so the VGG19 is actually given a good result in and around 95%. So that actually we are selecting this like the network for this particular methodology. So this is the confusion matrix, many of them know. So the confusion matrix is one of the performance metrics, especially we utilized for the classification problem. So in addition to that, like we have also compared this particular work not in a large volume of comparison, especially in terms of the lightweight comparison. So those who are having the different networks, and our network and our methodology, which we actually as producing very decent results, 92% accuracy, and also in other form of performance metrics like precision, recall, F1 score, like everything, in a very decent metrics. Okay, in some cases, some metrics, say if you look at the AlexNet, the F1 score is actually, some have given more than 2% of more than the F1 score. But if you look at the other, recall and precisions are very, very less. So in that way, actually we are justifying the selection of VGG19 network in the CSL classifications. So in addition to that, the generating receiver operating characteristics is also one of the important performance metrics, especially for the classification problem. So the what pre-trained network which you are using, we have also generated the ROC curve, but still the VGG19 is actually performing better than the other one. So in that way, actually this network is producing a good result in terms of the two-class problem of this epileptic seizures. So here, this, the work, the experiment, what we have been carried out, which have been given a lot of research direction to us. So in the research directions, say which includes uh, still the lightweight, even the lightweight networks are performing even better, than the high-end volume of neural networks. And in other way is that, so if you supply such kind of, the lightweight network, which we can go with multi-class, Caesar detection, not only for 2 class, that we can even go for 5 class problem with the Venn data set. So in that way, this experience, the work is given a lot of research direction to us. So in this case, what we have been done, so the idea has to be reformulated, and we have, ultimately, motivating to the development of lightweight neural networks for the multi-class problem. So if you look at this workflow, is similar to the previous workflow, but here the thing is that, of course, pre-processing is typically same, and we have different wavelet which have been done. But still, if it is going for the multi-class problem in the deep neural network, whenever which you are going to use, still the data is limited. So here we have done some data, augmentation techniques. So through the data augmentation techniques, we have generated a large volume of data. Then it is split into training and also the testing sets. So once the training sets are ready, so here what happened? So we have customized these networks. Say, we have tried, many pre-trained networks, but in the large amount volume and also the multi-class problem, even we have tested VGG19, what network which have previously used, that is also not performing well in this case. So what happened? So in this case, so like we have, customized our neural network, convolutional neural network in terms of lightweight environment. And moreover, still if you use this network, we need to improve the performance metrics. So in this case, what happens? So we have also added a hybrid mechanisms, we have used BiLSTM with the attention mechanisms. Then finally, what happened? This network is gradually the improved the result like anything in the multi-class. So this all experiments what we have been carried out to make it this effective methodology. So which all we have done from through various our experience and utilizing the different pre-trained network. And finally, we have formulated this methodology. Okay. So in this case, why we are saying lightweight network? If you look at only 3-layer CNN that we have been utilized in this works, only 3. And if you look at the BiLSTM, I think many of them are known BiLSTM. It's a recurrent neural networks. So that will ultimately helpful to improve the performance even in the in the recurrent mechanisms. And of course, attention we can use to the effective feature extraction. Then finally, the network will helpful for the classification case. So this is the typical workflow of this one. So this experiment, this methodology, even we have tried many experiments to prove the efficient of our particular methodology. So if you look at the, it is a classification problem. So we have a confusion matrix. If you look at the 5-class, and we have separately done for the CNN with LSTM or without LSTM or combined one. And finally, the all combined, the hybrid network, it is given a very good result so that the particular network is given a good metric in this case. In addition to that, as I said, it's not only for the confusion metrics, but also the ROC curve is also one of the important metric in classification problem. In this case, if you look at when compared to 2, the third one is actually given, the highest, curve characteristics in the area. So in that way, this particular network is given very good confusion metrics as well as ROC. Now, coming into the medical imaging problem, whenever which you are going to propose any methodology, so we need to perform the ablation study, right? So here that is a hybrid network. So we have also, tried many, the in the raw network with BiLSTM or without BiLSTM with attention, various combinations that we have tried. And all this case, if you look at the accuracies and all, the gradually it is actually given a good result. If you look at the first case, CNN with BiLSTM without attention, 92 is given. And without BiLSTM, if you look at the last column of the accuracy, it's given only 96. And if you combine this all, there is a large, gap in the accuracy, 99.4. If you look at the specificity, precision, and all 100, which we are obtained from this case. So that way, actually, the different combinations of, the network which have been tried to prove the efficiency of these networks. And being a researcher, to propose a very, effective lightweight neural networks, so we need to calculate the number of parameters which is involved in this methodology, right? So in this case, if you look at different parameters, the large, the hybrid network what we have been proposed is, very, very least number of parameter. So that way, actually, we can just justify this is one of the well-known lightweight neural network, especially for the CISA classifications. Okay. In addition to that, not only, the number of parameter, but also we have calculated average inference latency of the system. So if you look at in terms of milliseconds, the latency is also very, very minimum through this hybrid network. So this also, given you the direction is a developed lightweight network. Okay, so while performing all this, the performance metrics, the performance analysis, in simultaneously, which will also able to do the comparative analysis. So the comparative analysis we have done in different way. So this table is given you. It is based on the data set. So for example, as I said, the Ben is very a famous data set, and of course, who are supplied the result the recent time, the recent 5 years. So that we have also taken into the account. And of course, if you look at ours are performing very good results in this case based on the data set. And moreover, the analysis is also done for the the previous methods in different performance metrics in terms of the state of the comparison. Of course, this one is even performing very well. And so not only in terms of the previous methods, but also this work we have done a strong comparison between the lightweight model. So those who are already proposing a lightweight model, especially in a biomedical imaging context, so that network is also experimented by us. And if you look at even still this one is giving a very good metric. So what I want to convey to you is that, so if you are being the researcher, and what you have to do, if you proposing any methodology like this, so you have to perform various the performance metrics and comparative analysis, so that you can effectively prove the efficiency of your work, right? So that way, the proposed lightweight network in this is a case, so we justified in all these nook and corners. Yeah, so now the point is that, say 99.25 result which you are supplying in this Ben data set by this lightweight network, then what else next? How we actually we can improve further. In one case, right, say there are 0.75 percentage is actually deviation in this in terms of accuracy. So how to groom this particular way, and what way we can able to either improve this result, or maybe we can go for the if you want to, in lightweight network, is it possible to reduce even the number of parameter or latency time? So what way we can able to to groom this problem, So you can think into the multiple directions. So in that way, what you can do, even you can able to propose a very very small network, even lightweight network, and in the other way, how we can compromise the result with the lightweight network, how we can reach the optimum performance metrics of this network. So everything, like if you taken into this account, I mean taken into the takeaway point of from this particular talk, I think you can get some different or the new research directions to your, I mean, the research life. So here, of course, what we have done in one way, like say, we are utilizing, the simple hybrid network here in this case. And also we are, working on, especially for, the selection of the parameter in the deep network. So wherever which we are previously the lightweight network, which we are utilizing the training parameter manual kind of thing. But here what happened, that selection of parameter is also a challenge of the deep neural network. So while understanding this concept, so what we have done, the preliminary, the pre-processing mechanism is, the same. But here which we are using the kernel PCA optimization algorithm, especially in terms of selecting the hyperparameter of the deep neural network. So in that way, so how we can minimize the like the training time, at the same time how to get the optimum result in this case. So that way actually we are also working right now. So the development of ensemble network is not only network, but also we have CNN, BiLSTM, and BiGRU, all these networks. Then while combining all these weights, we are using multi-layer perceptron, MLP. So through this, how actually we can effectively classify this multi-class problem. That way, actually, still we are working on it. And we are also got some decent result in this case in terms of confusion matrix. So how the ensemble approach is helpful, especially for this type of elliptic scissors classifications. Yeah, so here I'm like, given to you a lot of research problem, research idea, so that you can also carry out this problem by understanding this lecture. So while concluding this today talk is that, like say, what we have discussed, in one way, like, how the one-dimensional signals can be converted into two-dimensional, and like what techniques we generally using, and also how actually the classification is can able to do that. In addition, what we have discussed, how the lightweight environment, the lightweight network is generally helping into the Caesar classifications rather than the high-end, the bulky deep neural networks. And also how we can use this ensemble approach for the selection of automatic hyperparameter optimizations. So especially for the improvement of the classification, that also we have been discussed. So I hope with this limited time, my talk is given to you in some inputs. And of course, the research is the endless process. Always, one researcher, can be killed by the other researcher. So in that way, from listening this particular talk, so you may be kill my previous research. So I will be a very happiest person. So maybe from my lectures, so some of the audience actually they are contributed for the betterment of the society. So that way we can compromise, this particular talk. So thank you one and all present here. Thank you, my dear friend Dr. Deepak, for giving an excellent opportunity to discuss some of my recent research outcome with this wonderful audience. Thank you so much. And if you have any queries, so I can happy to answer some queries in the rest of the time. Please. Any questions? I think all are hungry. Already 8:35. So many of the people are actually hungry, so that their eye is not opening. Deepak sir, you are not audible. I don't know why.
Now I'm audible, sir.
Yeah, perfect, perfect.
Sir, actually today will see also one working day.
Okay, okay.
So all might be tired also.
Yeah, I understood the practical difficulties. Yes.
Okay, sir. Thank you very much, Murugan, sir.
Yeah,
I think
thank you,
four
Deepak
times.
sir. Yeah. I
You,
hope
in our
within
four
this.
consecutive FTP, you have.
Yeah. I hope I have given a good lecture in this limited time.
Yes, sir. Yes,
So,
sir.
yeah, so let's see. Thank you so much, and we'll sign off.
Thank you. Thank you.
Thank you.
Okay.
Thank you, sir. Thank you.
Ma'am, thank you. Thank you so
Thank
much.
you. Thank you.
Thank you.
Bye.
Lipod, ma'am. We will meet tomorrow. Thank you. Thank you very much, all. Thank you. Thank you.